Okay, for this video, we're going to talk about subtracting real numbers, and I have four examples that we're going to look at. So we're going to look at decimals, fractions, and then a couple of other things. All right, so let's go ahead and get started. So you have to remember the rules for subtracting. We want to convert to addition. Symbolically, that means if we have A minus B, that's equal to A plus the opposite of B. So you can't just willy-nilly change a minus sign to a plus sign. You have to do something to compensate for that change in operation. And with subtraction, we convert to addition by adding the opposite. And then remember, if you're adding two numbers that have the same sign, you add and keep the sign. If you're adding two numbers that have different signs, you subtract and keep the larger sign. Okay? So we'll talk about all that when we get going. So here we're going to be subtracting decimals. Now, the only thing you need to remember about decimals is when you add and subtract decimals, you line up the decimal point. You potentially have to add zeros at the end of the numbers to make sure both numbers or all of the numbers that you're adding have the same number of decimal places. And then you just add or subtract and bring the decimal down into your answer. Okay, so let's first start by converting this to addition. We have negative 5.72 minus negative 12.3. So we want to keep the negative 5.72. And then we want to add the opposite of negative 12.3. The opposite of negative 12.3 is positive 12.3. So you can see here we're adding two numbers with different signs. That means we subtract the absolute values. So the absolute value of negative 5.72 is positive 5.72, and the absolute value of 12.3 is positive 12.3. So I'm going to take 12.3 and subtract 5.72. This is a situation where we do need to add a zero at the end of the number. I need a zero right here so that both of my numbers have the same number of decimal places so that when I do my subtraction, everything lines up correctly. So it turns out I cannot take 2 from 0, but I can borrow from the 3. 3 becomes a 2, 0 becomes a 10. 10 minus 2 is 8. I cannot take 7 from 2, so I have to borrow again. The 2 becomes a 1. The first 2 that we borrow from becomes a 1, and then the second 2 becomes a 12. 12 minus 7 is 5. Go ahead and drop down your decimal point. And then at this point, you can borrow, or you can just acknowledge that this one, if I borrow from it, it's going to become a 0, and this one is going to become an 11. Or you could just leave it 1, and then that little 1 that you've borrowed from, it just becomes 11. So 11 minus 5 is 6. So we're dealing with 6.58. If you don't believe me, verify with a calculator. The issue is we have to decide, is this going to be positive 6.58 or is this going to be negative 6.58? So we have to go back and figure out, what did we have more of? Did we have more negative or did we have more positive? Well, I have negative 5.72, or I have 5.72 negatives. I have 12.3 positives. I have more positives than negative. So that makes this final answer positive 6.58. Okay. So part B, we're going to rewrite this as addition. So negative 92 stays. But instead of subtracting positive 124.83, I'm going to add the opposite. So I'm going to add, and the opposite of positive 124.83 is negative 124.83. So now I'm adding two numbers that have the same sign. That means we add their absolute values. So the absolute value of 92 or negative 92 is positive 92. The absolute value of negative 124.83 is 124.83. So I'm going to add these two numbers. Notice I added a decimal and zeros at the end of 92. I just want to make sure decimal points line up vertically and that I have digits in each row or each column that I'm adding. So I'm going to start with 3 plus 0, which is 3. 8 plus 0 is 8. I'm going to drop down my decimal point. 4 plus 2 is 6. 9 plus 2 is 11. So I'm going to keep a 1, and then I'm going to carry the other 1. 1 plus 1 is 2. So right now I have 216.83, but is it positive or is it negative? Well, I was adding two numbers that were both negative, so that makes this negative 216.83. So adding and subtracting decimals is pretty easy. The new thing here is just dealing with that subtraction of negatives, okay? So let's go to example 4. So example 4, we're subtracting integers, or we're subtracting fractions rather. So we're going to go back to those rules for subtracting integers. We're going to convert to addition, and then we'll follow the addition rules. And then we have that added layer of dealing with fractions. So we're going to have to look for LCDs, equivalent fractions, and so forth. So here's what I do. I don't worry about the signs yet. I go ahead and I find an LCD, and then I find my equivalent forms, and then I start to worry about all of my signs. Okay, so remember, adding and subtracting, you have to have a common denominator. Since both the denominators here are prime, the product of those two denominators is going to naturally be the LCD. So the LCD here is 15. So then I have to ask myself, looking at 3/5, what would I have to multiply 5 by to get 15? Well, I'd have to multiply it by 3. But if I multiply a denominator by 3, I have to multiply a numerator by 3. And then we're going to look at 1/3. To get 1/3 into an equivalent form with 15 as the denominator, I'm going to have to do some multiplying. So what would I multiply 3 by to get 15? I would have to multiply 3 by 5. So if I multiply the denominator, I also have to multiply the numerator. So multiply top and bottom of both fractions by whatever number is going to convert the denominator to the LCD. And then we're just going to rewrite. We're going to just get the equivalent forms here. So I'm going to keep all the signs the same. I have negative 3 times 3, which is 9, over 5 times 3, which is 15, minus 1 times 5, which is 5, over 3 times 5, which is 15. So all I've done is find the LCD and the equivalent forms. Now I want to start to address what's happening with the signs. So this is what I do. I like to just push everything to the numerator. So I'm going to go ahead and deal with that addition or subtraction where we take care of the numerator and then we just keep it all over the common denominator. So I'm going to write this as negative 9 minus 5 over 15. Then I'm going to do a little side work to deal with just the numerator. So I have negative 9 minus 5, which we know is negative 9 plus the opposite of 5. So we have negative 9 minus positive 5. We want to add the opposite of positive 5, which is negative 5. We're adding two numbers that have the same sign. So that means we add 9 and 5 is 14. And since they were both negative, my result is going to be negative. So what this has become is negative 14 over 15. And those cannot be simplified. 14 and 15 have no common factors other than 1, so that's it. So you've got this extra layer here of dealing with the LCD and the equivalent forms, and then also dealing with the rules for subtracting. If you do both of them kind of one at a time, it's not that bad. All right, let's look at part B. So for part B, we have negative 3/5 minus negative 3/4. So again, we're not going to worry about signs now. We're just going to worry about the LCD and equivalent forms. So 5 is prime, 4 is not, but it's not going to really matter. If one of your denominators is prime, you're generally, and it's, so let me rephrase that. If one of your denominators is prime and it is not a factor of the other denominator, the product of those two numbers is just going to be your LCD. So in this case, the LCD really is just going to be 5 times 4, or 20. So 5 is prime. It's not a factor of 4. Just multiply the two. All right, so now let's figure out what we need to multiply both fractions by to get equivalent forms where the denominator is the LCD. So looking at 3/5, I need to convert 5 into 20. That means I would have to multiply 5 by 4. But if I multiply the 5 by 4, I also have to multiply the 3 by 4. Now looking at the second fraction, 3/4, what would I multiply 4 by to get 20? Well, I'd have to multiply it by 5. So if I multiply the denominator by 5, I have to also multiply the numerator by 5. So we know what we need to multiply. We've got our LCD. We just need to get those equivalent forms. I'm going to leave all of the signs the same. So I've got negative. Now it's 3 times 4, which is 12, over 5 times 4, which is 20, minus, and then in parentheses, I have negative, and then 3 times 5 is 15. 4 times 5 is 20. You don't want to reduce at this point. We get so in the habit of reducing fractions, but this is the one time don't reduce them, because if you reduce them, you just go right back to uncommon denominators and you have to do this whole process again. All right. So now is where I'm going to float all of the signs and the numerators just to the top of this, and then I'll keep the common denominator. So here I have negative 12 minus negative 15. All of that is over 20. All right, off to the side, I'm going to do a little side work. I've got negative 12 minus negative 15. I want to convert that to addition. So I keep the negative 12, but instead of subtracting negative 15, I want to add the opposite of negative 15, which is positive 15. So I want to add positive 15. So now I'm adding two numbers that have different signs. That means we subtract the absolute values. The absolute value of negative 12 is 12. The absolute value of 15 is 15. 15 minus 12 is 3. But then you have to ask yourself, is it positive or negative? Well, I had 12 negatives, but I had 15 positives. Since I had more positives than negatives, the result is going to stay positive. So this over here just becomes 3/20. And at this point, you would look to see if you could simplify. 3 and 20 have no common factors, so that would be your final answer. Okay? So that's example 4. Let's go ahead and look at examples 5 and 6. All right, so example 6 says simplify. And the only difference with example 6 is you have more than two numbers that you're adding or subtracting. So this is what I like to do. If I'm adding or subtracting 3, 4, 5, 6 numbers, I go ahead and convert everything to addition. So if I see a subtraction anywhere, I convert it to addition. And then at the end, I just follow the rules for adding several numbers. So when I look here, I have -9. This is example 5, part A. I have -9 plus 7. That's addition. I don't have to worry about it. But then I have minus -12. I don't want to keep minus -12. So I'm going to rewrite this as -9 plus 7 plus, we want the opposite of -12, which is +12. And then notice I also have minus +21. Well, I don't want the subtraction, I want the addition. So instead of subtracting +21, I'm going to add the opposite of +21, which is -21. And then at this point, everything has been converted to addition of positives and negatives. So you have options. You can just add from left to right, or you can get your negatives together and your positives together, add those, and then do your final addition. So let's practice that just for the sake of fun. So let's look at just the negatives first. I had -9 plus -21. And then after that, I had +7 plus +12. So we're going to kind of add each half. All right. And the reason we sometimes do this is it's a little bit easier to add numbers with the same sign because you just add and keep the sign. So I've got -9 plus -21. Since we're adding the same sign, we just add and keep the sign. So we take the absolute values, which would be 9 and 21. 9 plus 21 is 30. Since they were both negative, it's going to be -30. Now for the other half, we had +7 plus +12. Adding the same sign, we just add. 7 and 12 is 19. So I have -30 plus 19. Now I'm adding two numbers that have different signs. This is where we subtract. So I want to take the absolute values and subtract them. So the absolute value of -30 is 30. The absolute value of 19 is 19. I want to subtract. So if you can't do this one in your head, that is fine. Do the side work. We can't take 9 from 0. So we convert the 3 to a 2. We borrow. The 0 becomes a 10. 10 minus 9 is 1. 2 minus 1 is 1. So we get 11. But is it positive or is it negative? So I want to ask myself, what do I have more of? Do I have more positive or do I have more negative? Well, in this case, I have 30 negatives and only 19 positives. That means I have more negative than positive. So my final answer is going to be -11. Okay? Now for part B, we have fractions, and everybody gets kind of worked up about fractions. Looking at this set of fractions, the denominators are 4 and 8. Okay, so we want to find the LCD. That's the smallest number these denominators divide into. 4 and 8 are not prime, but if you look at 4, it is a factor of 8. 4 divides into 8, 8 divides into 8. That makes the LCD here just 8. Okay, so I'm going to do like I did in the previous example, and I'm going to convert all of the fractions that do not contain 8 as the denominator. I'm going to get equivalent forms of those using the denominator of 8. Okay, so first let's look at the first fraction. We have 3/4. What would I multiply 4 by to get 8? Well, 4 times 2 gives me the LCD of 8. So I'm going to multiply top and bottom by 2. If I look at the second fraction, it also has a denominator of 4. So I would multiply top and bottom of that by 2. And then I want to just rewrite this expression. I'm going to keep all the signs the same. I'm just going to get those equivalent forms of the first two fractions. So the first fraction was negative. It's going to stay negative now. But now it's going to be 3 times 2 is 6 over 4 times 2 is 8. And then I'm going to subtract the second fraction, which is going to be 1 times 2 over 4 times 2. And then I'm going to subtract -5/8. I have not changed a single sign. Everything is exactly the same. We just got equivalent forms of those first two fractions. Now I'm going to take all of the signs and all the numerators and float them to the numerator, and then I'm going to keep the common denominator. So this is going to be negative 6 minus 2 minus negative 5 all over 8. And then off to the side, I'm going to deal with that numerator. So I have negative 6 minus 2 minus negative 5. Just like in part A, I want to convert everything to addition. So negative 6 stays the same, but instead of subtracting positive 2, I'm going to add negative 2. And instead of subtracting negative 5, I'm going to add positive 5. So each subtraction we converted to addition by adding the opposite. Okay? So now let's just add. We'll go left to right here. So negative 6 plus negative 2. I'm adding two numbers that have the same sign. So I want to add and keep the sign. So 6 plus 2 is 8. And since they were both negative, this is going to be negative 8. Drop down your plus 5. So now I'm adding two numbers that have different signs. I subtract. And remember, secretly, when we add or subtract, we're taking the absolute values. The absolute value of negative 8 is 8. The absolute value of 5 is 5. 8 minus 5 is 3. But then we have to ask ourselves, is it going to be negative or positive? Well, since I have 8 negatives and only 5 positives, I have more negatives, so that's going to make this negative 3. So my final answer, the numerator is negative, denominator is positive. I get negative 3/8. They have no common factors, so you're done. All right, the final example, example 6, we're going to work with some absolute value again. You keep hearing absolute value, so we might as well practice. All right, so what you want to do when you have the absolute value of some operation, addition, subtraction, multiplication, or division, you treat the absolute value almost like grouping symbols. You want to take care of what's inside first and then apply the absolute value. So off to the side, we're going to do a little side work. We're going to look at negative 15 minus 10. So I'm subtracting two integers. I want to convert to addition. First integer stays the same, and then I add the opposite. Since I was subtracting positive 10, I want to add negative 10. So now I'm adding two numbers with the same sign. I add those absolute values, so I add just 15 and 10, which is 25. But since both of those integers were negative to begin with, my 25 is going to be negative as well. So now I'm going to go back to the original problem, and I'm going to say, okay, this is equal to the absolute value of negative 25. And just remember, absolute value is a number's distance from 0. So how far is negative 25 from 0? It is 25 units to the left. So even though it's to the left of 0 and negative, it's still positive 25 units away. So we would say the final answer here is positive 25. Now, example 6, part B. What you need to notice here is there is a negative in front of the absolute value. So this is like negative 1. I'm going to write it like a kind of more traditional one. It is negative 1 times the absolute value of 27 minus 40. So let's just go ahead and to the side, deal with 27 minus 40. I want to convert that to addition. So we're taking 27, we're subtracting positive 40. That's going to be 27 plus the opposite of positive 40, which is negative 40. So I'm adding two numbers with different signs. That means we really subtract the absolute values. So the absolute value of negative 40 is 40. The absolute value of 27 is 27. So I'm going to subtract 27 from 40. If you can't do this one in your head, do the side work. I cannot take 7 from 0, so I borrow from the 4. 4 becomes 3. 0 becomes 10. 10 minus 7 is 3. 3 minus 2 is 1. So we have 13, but is it positive or is it negative? Well, I had 27 positives, but I had 40 negatives. That means I have more negative than positive. So this 13 is negative. So that's like we have negative 1 times the absolute value of negative 13. We'll go ahead and take care of the absolute value. What is the absolute value of negative 13? Well, negative 13 is 13 units to the left of 0. So we would say that the absolute value of negative 13 is positive 13. But don't forget that negative that was in front of the absolute value to begin with. This is the one time you're dealing with absolute value and you'll get a negative. If there's a negative out front, you multiply your final result by negative 1. So that makes the final answer here negative 13. And that's it. So we've looked at visualizing subtraction on a number line, the basic rules for subtracting integers, and now we've looked at subtracting real numbers. So we did fractions and decimals. We looked at adding and subtracting more than one real number, and then we've also looked at absolute value. So make sure you practice, especially those basic rules. Whoops. Make sure you practice subtracting those basic rules, so just converting it to addition and then following the addition rules. And if you did not get enough practice with adding integers, make sure you practice that too.